So a relevant question is, well, what happens if the point of discontinuity is in the middle of the interval given? In this case, we have the integral from 0 to 5 of dx over x minus 4 with a point of discontinuity at x is equal to 4. Well, what we do is we try to split up the integral at the point of discontinuity. In this case, we evaluate the integral from 0 to 4 of dx over x minus 4 plus the integral from 4 to 5 of dx over x minus 4, assuming that both of these integrals converge, which is not a fair assumption. So, in order to evaluate these, we do the limit as a goes to 4 from the left of the integral of 0 to a of dx over x minus 4 plus the integral of b as b goes to 4 from the right of the integral of b to 5 of dx over x minus 4. Well, the antiderivative of both of these parts is the natural log of the absolute value of x minus 4. And as we plug in either a or b and evaluate the respective limits, in this case on the left we would evaluate the limit as a goes to 4 from the left of absolute value of a minus 4, we find that those limits do not exist because the input is approaching 0. And that's not a good thing for a natural log function. If the limit does not exist, we say that the integral diverges. So if one part of the integral diverges, then when we try to put it together with another part, the overall integral will diverge as well. Now, if you had ignored this discontinuity and just tried to evaluate it like normal, for example, you said the integral from 0 to 5 of dx over x minus 4 is equal to the natural log of the absolute value of x minus 4 evaluated from 0 to 5, plugged in 0 and 5, we would find out that we would get an answer of negative natural log of 4. Well, that answer really isn't valid because you haven't bothered to address the fact that this function has a discontinuity. The FTC is only a theorem that is applied when the function is continuous. In this case, since you ignored the discontinuity, you've performed an operation that just doesn't make any sense. So be careful. You need to make sure that when you look at integrals from now on, you spot any points of discontinuity, and if you have any, make sure to address them appropriately.